and wave solder process. We're also going to give you a quick overview of our process checklist app that we've developed to help troubleshoot customers' process issues. My name is Robert Wallace. I will be your host today. I'm the Regional Marketing Manager and Channel Partner Manager for the Americas for Alpha. I've been with Alpha almost 26 years now. Alpha and Hisco have had a very long and beneficial association. We've had a great partnership. We manufacture products. Hisco basically helps us take those products to market, and they take care of our customers and supply those products exactly when our customers need them. Hisco approached us several months ago with the idea of having a webinar series, an informational webinar series to benefit our customers. We thought it was a great idea, and we certainly fully supported that, so here we are. The webinar series started on Monday. Obviously, this is the fourth in the series. Today's webinar, like I said, is troubleshooting the SMT and wave solder processes, as well as giving you a taste of our new process checklist app. I just want to go over some ground rules real quick. Please mute your phone or computer so that we don't hear much background noise. The total presentation is going to last probably somewhere in the neighborhood of 45 minutes or so, and today is actually broken out into 3 segments that are going to last about 20 minutes. At the conclusion of each one of these segments, I will open the floor for questions. You're welcome to ask a question at that time, or if you would like, you can type a question, and Dave from Hisco will basically he will read those off when we get to the question and answer session. You should be looking for an email in the next couple of weeks with information from Hisco. It's going to be the troubleshooting guides that we're actually presenting live today. There's an SMT troubleshooting guide and a wave troubleshooting guide. You're going to get those electronically. There will also on that email.
I'm training right now. I'm on a meeting right now.
I'm sorry. Can somebody mute their phone, please? I hear the. Okay. The email will also have a link with an e-book that has related technical articles, so look for that. If you think of a question later after the webinar, on that link you will have my email address as well as the presenter's email address today. You can certainly email us anytime with your questions, and we'll make sure and respond to that. And then I would remind you of the upcoming webinar. There is one tomorrow on LED product line. We're going to introduce LED basics. We're going to talk about the different hierarchies of the different levels of LED, 1 through 5. We're going to basically introduce those to you and then talk about Alpha products specifically for LED applications. I would encourage you to go on the Hisco website and register for that. Okay, so today's presenters are from what we call our Customer Technical Support Group. Their mission and purpose is to aid our customers in the best use of our products. They answer technical questions. They do that via phone and via email. Certainly everybody on the attendees on the call today should be familiar after today with their Customer Tech Services Group. Frank and Bruce will be presenting the first part of it. I'll introduce those individuals to you before they come up for their presentation. And like I said, I'm going to introduce those folks individually. So first up is our SMT troubleshooting portion of it. Frank Andres is going to be your presenter. Frank is a North American Customer Tech Service Support Manager. He has 15 years in the SMT industry and 4 years in the thin film and fiber optics industry. He holds a degree in chemical engineering from the University of Rhode Island. And for those that have not met Frank personally, he is freakishly tall. So without further ado, Frank, I'm going to go ahead and hand it over to you. And please start the SMT troubleshooting portion of our presentation.
Okay. Thank you, Robert. I don't know exactly how to ask this question. If you can't see my screen, go ahead and unmute yourself, but can everybody see my screen?
Frank, if they would type a 1 in their chat box,
there you go.
We'll get an idea. That's a good point. Right.
All right. So type 1 if in the chat box if you can see the screen.
And Dave, you'll let us know if we're not getting 1 typed in.
Okay, fantastic. Okay. All right, so just to keep on time here, I'll go forward with this. If you can't see the screen, then we'll have to try to work through that as we go along. But this troubleshooting guide, just to put it into proper perspective, is it starts relatively simple. It's a high-level troubleshooting guide meant to help the customer start looking into their process and find the solution. So it doesn't go into extreme detail. It's not a FMEA, failure modes and defects analysis. It's not that. We do that and we get into in-depth troubleshooting, but the purpose of this is to enable the customer, whether it be new people on the floor who aren't as familiar with the process, or sometimes some of the experienced engineers can't always see the forest through the trees, so you can take a step back and go through the basic stuff before getting more complicated.
Big Jim, what's going on?
All right. If you could mute your phone if you're not actually...
I've heard of that call before. I've heard of that place. I drove by there, so it's half mine, right?
Okay. We have some chatter in the background. Please mute your phone.
How big was what?
It looks like... okay, we're good to go now. So what I want to go through really quick here is the structure of the troubleshooting guide so that you can pick it up and you can run with it. It's important to note that every process out there is somewhat unique, so you can't possibly cover somebody's doing something here on my screen. Okay, you can't possibly cover every single detail of someone's process without spending a lot of time there and going into it. So this is going to cover it at a high level, and you can see here we have about 8 or so, 10 or so defects that are common in the industry. And going to the next.
I think somebody else has control of your screen. You're going to have to grab control back.
Yeah, how did that happen?
I think they just basically clicked on maybe by mistake. So you're back. We're good.
Okay. All right. So I'm on the pages 3 and 4 of the troubleshooting guide. You should be able to see that. So the way this is structured is simple. Bridging. We go through a quick definition. So I won't be able to do this for every single defect we talk about, so I'll just go through some of them, and it'll be similar for the other defects. So I think most people are familiar with what the bridging is in the SMT with the solder paste. Wet bridging, post-reflow bridging. We start with the definition, then we go to possible causes. So you'll see we talk about the PCB. So the surface mount device, the pads can contribute because of coplanarity. So again, these are simple things, high-level things. You can rule them out quickly. Hopefully, this stuff can be ruled out and you go on to something more complicated. Then you can see we go down to the next possible cause. We talk about stencils. Now, there's a few different things that stencil can contribute to, right? The tension, your aperture designs. If you follow through this, each individual step, what it does is it starts a conversation. It's not that these individual, it's some sort of a go, no-go, and you follow each individual step, you'll come to the conclusion of the problem. That's not the intent of this. The intent is that it starts a conversation so you know how this particular attribute may contribute, and you can see whether or not that applies to your process or not. If it doesn't apply to your process, then by all means just skip over it and go on to the next thing. So if we go on to bridging, you can see here that board support, right, is typically one of the most important things. So how well do you gasket? And that was going to contribute to your possible bridging. So this is a screen printer, possible things within the screen printer process that will contribute to the defect. The alignment, how far off are you? And it's more critical for things like QFPs and maybe for larger passive devices when it comes to bridging. So you do have to have some experience to weed through this, the different aspects of this. We're here, Alpha's here to help you. If you have questions with it, then yeah, by all means, our sales folks and our CTS guys can help step you through each one of these individual issues or recommendations to see whether or not it is applicable to your particular process.
Hey, Frank, let me interrupt and stop you here for a second because, again, this is Robert Wallace with Alpha. I do see that a number of people have joined maybe since I made the introduction. Frank Andres, who is our manager of our Customer Tech Services group, is speaking. And what we're presenting to is actually a PDF representation of what we call a troubleshooting guide. In this case, it's our surface mount troubleshooting guide, right? So what you're seeing here is a graphical representation of what we have in a little booklet form that either we can send to you, we'll send to you after the conclusion of this webinar in electronic form, and or have your HISCO representative and your Alpha representative hand carry one out to you and discuss the issues maybe that you're having. So Frank, I just want to remind everybody, you know, we have better graphical PowerPoint presentations, but we're speaking specifically to a piece of literature that we have available for all customers. Okay, Frank, go ahead.
Correct. Yeah, and again, Robert, just to reiterate there, it's meant to start the conversation with respect to troubleshooting. Obviously, if you're able to solve the problem, you would have done it. But if the problem persists and you want to try to get focused and started on exactly what's happening, then this troubleshooting guide is meant to start that conversation, get us all on the same page and looking at the process the same way so that we can start simple, rule out very simple causes and go to more complicated causes, which would take obviously more time to troubleshoot. So in the end, if you properly troubleshoot this, you should be able to turn the defect on and off. So bridging, for example, if you have an issue with bridging and we look at the misaligned print. So if you go out to the process and you see that your print is misaligned and you're creating bridging, if you set the offset so that you get the best possible alignment and the defect goes away, then you have a high degree of confidence that alignment was the issue. So what you can do is you can take that offset out, go back to making it misaligned, and if your bridging defect comes back, then you're really confident that the problem was solved. So bridging, it really is very common, and we do have quite a bit on that. So, you know, we looked at the process, we looked at some of the inputs. All right, someone, yeah, thank you. Component placement. So it's very systematic the way we work through this. And if you're confident your component placement is all really good, then you can skip that part, and then you can go on to the reflow profile and the solder paste. So we want to be able to give you a systematic, logical approach to solving the problem where you can actually, when you get done, you can communicate back to your organization how you step through. You know, here's a definition of the problem, and then the various things that you step through to prove or disprove that it was a problem. So that's the whole approach. So moving on to insufficient solder fill, you know, and then you have insufficient solder. So, you know, maybe you don't fill up the complete area, or maybe you don't have enough volume. So it's important to distinguish between those two things. So the troubleshooting guide helps us to use a common language so that when we engage each other in the problem solving, we're not wasting, we don't misunderstand what the actual defect is and send you down the wrong path. We have a really good idea of exactly what the defect mode is, and then we can try and figure out what the mechanism is based upon that mode. And Robert, you were going to hold questions to the end, correct?
Yes, till the end of your segment.
Okay, all right, so a couple more minutes here, and I'll just breeze through the selector guide, and then we'll go to some questions here. So insufficient solder then, random solder balls, again, you know, the way this is structured, there's a definition, and then you have probable causes with the stencil, with the reflow profile, with the PCB, or with the solder paste. There can be more reasons why you're seeing this defect, but these would be some of the more common ones that we would want to rule out before getting more complicated.
So Frank, what we're talking about here is for the individual defect, we outline or we identify most of the potential causes so that a customer, if they're trying to debug their process on their own, using this troubleshooting guide, they've got a good framework to start with. They could use this as, for lack of a better term, as a checklist to go down the potential causes for that defect. And if they're able to turn it off and on, then they're really kind of, you know, focusing in on the actual problem. Is that a fair statement?
Yeah, that's very fair. Robert, one of the key words you said there was framework. It can be a lot more complicated. You know, I let the other CTS engineers speak for it, but, you know, out there in the field, we're at, you know, 50 to 100 different sites a year. We see a lot of different processes, and the customers do a lot of things differently. And they have to. It's a good reason, because of the product they're building, because of the technology they're trying to enable. So it can get very complicated. But through the years, we consistently see that there are some core fundamental things that need to be checked off first. They need to go through every time to make sure, okay, I'm in the ballpark. Everything seems, this is my baseline, it's stable, everything should work. Now it's not working, what specifically isn't working about it? And then you look at the inputs, you know, the input to a print process, you have the printer, the stencil, the paste, and the board. So somewhere in there, if you're trying to troubleshoot a print defect, you're going to find the solution. So we tried to structure it so that you can look through each one of those and what are the simple or more common occurrences that would generate that defect. So go on to paste drying, solder spatter. It could be solder, or it could be flux. It could be coming from the paste. It could be transferred within your process. So we walk you through what's going on there. You know, is it present before it goes into the oven? If it's present before it goes into the oven, then it's not because of the oven. You have to look upstream of that. But that's a critical delineation. A lot of people see spatter on a gold finger coming out of the oven. Their assumption is it's happening during the reflow. Not always. Often it happens before the reflow, either in the pick and place or more often in the printer itself. Midship solder balls, we've all run into those through the years, and you know, these are board, you know, design is really critical. The stencil design, again, that's something critical. The printer obviously can, and component placement by far is one of the more common reasons for midship solder balls. Tombstoning, it gets very, very complicated with, it's a force imbalance, and that force imbalance can be generated in the oven, or it can be generated due to the design of the system or the pick and place. So understanding exactly where the defect is initiating and what the process window is for each part is important. So we step you through here some of the designs, good design versus bad design. And again, these are relatively simple, straightforward ones. They're in line with the IPC recommendations and whatnot. Voiding is another one, and you know, it's important to say what kind of void you have. Do you have a bulk void, or do you have an interfacial void? Or is it a void on a heat pad, a heat sink? There are different mechanisms that generate each one of those. If it's a bulk void, often it can be due to outgassing and due to the flux chemistry, so you want to make sure you're looking at your reflow profile and the amount of solder paste you're putting down. If it's an interfacial void, then often it could be due to metallization, so it's important to look at that. If it's under a heat sink, then very often it could be paste imbalance. So stencil design can have a big impact on that, as well as outgassing. So there's multiple mechanisms for each defect mode, trying to break them down and present them in a logical way so you can move the troubleshooting process forward is what we're trying to do. We look at head and pillow. People have seen that a lot. Actually, I think we should include non-wet opens now in this. We've learned a lot about non-wet opens, so we'll probably update it to include that. And then grainy solder joints. So that's a troubleshooting guide outline. Feel free to pick it apart. It's not something where, like I said, if you start here and you go all the way through it, we guarantee it's going to solve your problem. But if you start, it's going to provide a systematic approach to troubleshooting, allowing you to capture the information you've learned at each step as you go through it. So when you come to the end and you have resolution, you can communicate back to your organization what you did and what was successful and what wasn't successful. So Robert, I think I kept to time pretty much. Maybe I have an extra minute or two.
I think you're on budget on time. So again, for the benefit of everybody that may have come into the presentation a little bit late, what Frank is highlighting here is our troubleshooting guide. It's actually a booklet that we provide to our customers. You're going to get an electronic copy of this as well and an email from Hisco. And so all we're doing, what we wanted to highlight was the fact that this guide gives you, if we identify the most common defects, it gives you the most common reasons or what could be happening to produce that defect, and maybe some very simple remedies. This starts the conversation. Realistically, you need to engage with your Alpha field salesperson and or our Alpha customer tech services support person, and that was really the goal of today, is to introduce you to our group. So if you look at any one of those defects, and let's say voiding, we could have spent an entire half-day webinar on any one particular subject. So we're giving you a lot of information in a very short amount of time. We're going to open up the floor for questions. If you have specific questions about a defect that you might be experiencing, now is the time to ask. So the floor is open. Also, if you wanted to type a question in your chat box, Dave and Hisco will basically read those off. So one or two, the choice is yours. Voice it now or type it in, or if a question comes to mind later, you can email us with a question.
All right, thank you.
Okay, I'm going to wait another few seconds for any questions from the floor. Frank, can you switch control over to Bruce, please? Or Bruce, can you take control?
Yeah, I'll switch over to Bruce. Bruce Barton will be presenting the wave solder troubleshooting guide, which is structured a little bit differently than this, and that's in part because of it's more of the variables are codependent. You change one thing, you change multiple things. One variable, you change multiple things. But I seem to have lost control here, so let me get control back.
Yeah, no, I think Bruce has control.
Oh, do you have, Bruce, do you have control?
Bruce, you may need to unmute your phone. Okay, I see a wave soldering troubleshooting guide up on my screen. Bruce, are you there? Okay, we have Bruce visually, but we don't have him via audio.
Can you hear me now?
There we go. Bruce Barton. All right, Bruce, let me make an introduction. So Bruce will be handling the wave soldering troubleshooting guide. He'll be walking you through that. Bruce Barton is our customer tech support engineer. He's been with Alpha since 1995, has a very colored history, a very honorable history. He served in the Marine Corps as an H-1 helicopter mechanic, door gunner, and crew chief. After the military, he graduated from Coleman College, and he's worked in the electronics industry for the past 28 years, and certainly a very valued member of our customer support team. And so, Bruce, without further ado, you have the floor.
All right. Thank you, Robert. If anybody has trouble hearing me, please let me know. We're going to cover the wave soldering troubleshooting guide, and it follows pretty much the same premise as we just talked about for the SMT guide. Thank you. Again, the construction of the document, the guidance through the basic troubleshooting process is the same. As we go through this, please take a note that a lot of times when we get to, I have a problem, how do I solve it, the potential problems are you have too much flux or you don't have enough flux. So that's a very common thing that we see. Some people, operators, whatever, think if this much flux is good, then that much flux should be better. And it's just basically not a true statement at all. So be careful on that. Again, we're going to cover bridging. The primary areas, setup areas to check. Okay, your conveyor, preheat, etc. Other things to look in the process. Is your solder pot temperature too low? Perhaps your thermal sensor has gone bye-bye and you need to replace it. Solder wave height is too high. If you have a blow-off subsequent to your wave, the blow-off could be too high. Just things like that as you go through. You not only need to look at your process, but you need to look at your assembly. Is your pin-to-hole ratio correct? Are the ground planes properly thermally relieved to allow a wave soldering process? Other things to look for, board contamination, component lead length. I believe the standard for protrusion under the bottom surface of the board is 0.62. And if you get longer, that's pretty long and could contribute to bridges, but it's the accepted standard. As you get longer than that, bridges will definitely appear on your product. How old is the board? How is it stored? How about the mask material? Is it properly cured? Does it have bubbles? Does your board have contamination? Has it been sitting out and has perhaps oils from the air, things like that? Board design, internal ground plate, weight distribution, component orientation. Many times we can troubleshoot by taking a board with a known issue, rotating it 90 degrees, and running it with the exact same process, and it has no more bridging issue. So orientation is definitely important. Insufficient solder topside fillet. We're getting a lot of information about this and quite frankly concern from customers with the advent of lead-free processing. IPC says 50% hole fill is acceptable. A lot of customers don't like to do that. There's a few ways to look at this and try to solve it, up to and including doing your through hole during your SMT mounting process. I believe that's another webinar. Things to look at in the process. Solder temp too high, solder temp too low. You can see by reviewing these recommendations that the wave has a definite plus and minus to it, a process window And once you get outside the recommended process window, you're probably going to run into problems. So you ran a board fine last time, you go to run it again a year later, and now you have all kinds of problems. Well, what's changed in the profile? What's changed in the process? Okay, good idea. If your operators or your engineers are making process changes, they should probably log it. Bottom side fillet, insufficient. You have a minimum 270 degrees for class 1 and 2 boards on the circumference. A lot of times that can be affected by pin to hole, lead to hole ratio, contamination on the through hole walls, solder wave not being even, other things, look at the board design, etc. It's a step-by-step process as we define here. De-wetting and non-wetting are usually associated with either the process or more commonly the board itself. Again, what's the age? How has it been stored? How has it been handled? Okay, all things you need to look at. They're fast, they're quick, and it just leads you down further and further until we can get to resolution of the problem or initiate a call to Alpha support system. Solder voids and outgassing. Topside overall board temperature is too low in trapping moisture at this that is outgassed at the wave. One of the main things about preheat is you have to hit the proper temperature at the proper time. In, let's say, a VOC flux, if you don't hit the proper temperature, you're going to have micro droplets of water when that board hits the wave, and it just bursts, flashes into steam, and can result in blowholes, pinholes. How about your flux application? Are you sure you're getting flux on the entirety of the board? If you have a component in the shadow of a surface mount part and the flux doesn't get it right, you can see the pinholes, blowholes, non-wetting, de-wetting. Okay. Solder skips. If you're doing SMT components, you probably want to have a chip wave in addition to your standard lambda wave. If you're getting shadowing, i.e. no solder joint on one side, not the other side, your conveyor speed could be too fast. Wave solder could be uneven. Flux is not making contact. Board is not seated properly in the pallet that carries it. Board pallet is too hot when you put it in, when you send it through the oven, through the wave. Board contamination, improper board handling, pad size mismatch. Again, write down the list. Icicles and flags, we cover this also. Primary process, conveyor speed is too slow. Your solder could be too low of a temperature. You could have potentially a high amount of copper, which changes the fluidity of your solder. Solder balls and spatter. It's probably the easiest problem to address because it usually is process related. First thing to look for is open the wave solder machine as the board approaches the wave and listen for a sizzle and steam. That is the flux that the carrier hasn't been driven off. It's either water or alcohol. It is explosively turning into a steam and it's ejecting solder balls randomly across your board. A splashback, non-random, etc. The second page, solder balls and spatter. Solder on mask. Solder on mask can occur on the solder resist, board surfaces, pallet surfaces, and conveyor fingers. Flux application, flux and resist incompatibility. These are chemistries, and it's never a good idea to mix them in if they're not intended and proven to work. Rough or disturbed solder, usually a conveyor chain, pick and place machine adjacent to the wave machine or insertion machine that's causing excessive vibration just due to its positioning, things like that. Your pallet design is definitely something you need to check if you're seeing rough or disturbed solder. Grainy and dull solder. Impurities, intermetallic compounds, dross mixed into the solder, insufficient heat, conveyor too high, board contamination. Again, you'll see a lot of repetition as to potential causes throughout these guides, but certainly in several situations it's applicable. Lifting of components could be conveyor too fast, wave height too high, board not seated right in the pallet. Could be a, if you say, built-in plug-in board, plug-in component, and the whole breaks off during the assembly process. That could be a cause too. Flooding. Board warpage, wave too high, preheat too high, conveyor speeds too high or too low. Most commonly, it's board warpage. Excessive solders. You're getting too much, you're not fitting the IPC definition of class 2 or 3, whichever you're building to. And we give a listing of probable cause that are quickly checked. That's it for me. Are there any questions?
Any questions from the floor? And Dave, has anybody typed a question?
Not to this point. I would ask everybody to please type their questions instead of trying to respond over the phone. Thanks.
Okay. All right, so if there is no type questions that we can respond to pertaining to any of the materials shared thus far, actually, Jason, if you could take control and get you queued up, right? And there we have it, the beautiful shot of the beach. Okay, so while Jason, I'm sorry, Bruce, thank you very much. And while Jason is getting queued up, let me just say again, if there are any questions, you can either type them now. If you would like to speak with one of our customer tech services engineers one-on-one, you're more than welcome to email them individually. I think on the link that you signed up on here, you did see, or you should have seen, their individual email addresses. You will be getting an email, a thank you email from Hisco that will have that information on it as well. So we're here to help, obviously. All right, we're going to switch gears now, and we're going to talk about our process checklist tool. We're going to give you a little bit of a teaser on that. It is an app that we've come up with to help our customer tech services engineer professionals out in the field walk through a customer's process and help debug a problem that you may be having. And it's basically an iPhone or an OS-based app. Jason Fullerton is going to walk you through that. Jason is our customer tech services engineer. He's been with us since 2013. He holds a bachelor's degree in manufacturing engineering from GMI Engineering and Management Institute, now Kettering University. He's worked in the electronics industry and manufacturing operations for automotive and high reliability assemblies, and is a member and past officer of the Philadelphia SMTA chapter. He's a Six Sigma black belt, is ASQ certified, is an ASQ certified quality engineer, and a former master IPC trainer. He's published and has presented at numerous IPC and SMTA meetings and expos. And so without further ado, I give you Jason Fullerton.
Hey, thanks a lot, Robert. I'm here today to present the new tool we've developed for helping work with our customers out in the field. We call this tool the Alpha Assembly Solutions Process Check. So what this tool is, it's really, like Robert said, it's an app. It's an iOS app that we contracted some developers to put together for us to help the CTS group review a customer's SMT and in the future wave solder processes. The way we administer this tool is informally, but it's also done in person typically. It takes about 15 to 30 minutes all told to go through one of the processes, and it's really kind of a walkthrough between the customer tech support engineer from Alpha and the staff of the customer, production staff, engineers, technicians, you know, whoever the appropriate responsible person would be at the facility. And so a couple of benefits of this app. One of the primary reasons we developed it was to help our customers demonstrate to their customers that they're engaged with their suppliers and that they're using the recommendations Alpha provides in our technical bulletins and developing a process that's going to be well optimized for the materials that are in place. This can be especially important for EMS providers that have to demonstrate to their end users that they have a good, well-developed process in place for all their products. It's also good to use in situations like automotive where you may be a Tier 1 or Tier 2 supplier and you have to ensure that the ultimate OEM is satisfied with the level of expertise and assistance you're getting from your supply chain. Another good reason and another good benefit from this app are that we can identify areas where the SMT process, although currently working well, may have some opportunity for optimization and improvement in the future. This can be very important when you have an existing process that is well developed and well controlled, but you start seeing more challenging designs or applications in your future roadmap or showing up on some of your NPI builds. There may be some opportunity to improve the process and widen that process window to ensure these new higher technology designs can be used and built properly with the existing material set, or potentially identify areas where you may need to work with more advanced material, where the existing material may not be up to the challenge of these new designs. And finally, one of the reasons we developed it as well was to try to identify and provide a baseline for the existing process in place when we're working with customers to help troubleshoot or diagnose root cause of a process issue or defect. Like Frank and Bruce just presented, there's some relatively straightforward kind of Pareto principle, 80% of the defects can be related to these things. But once you've worked through that list and you start getting into more and more detailed analysis, making sure you standardize the analysis process is important, because a lot of times engineers tend to get a little tunnel vision or a little bit of what we call, lose track of forest through the trees. And you may forget to look at certain aspects of the process at your first level view. This way it enforces a robust and consistent means of diagnosing the root cause regardless of what tech support engineer is engaged in the problem. All right, so there are really right now two different modules in this app. We have the printing and solder reflow modules completed and released, and they've been through beta. We have future plans to develop a wave solder and selective soldering complement to this app. However, they're a little bit more complicated than printing and reflow, so we kind of put those off until we got the tools out into the field and into the hands of the CTS group worldwide. All right, so this shows a screen from the interface on the iPad that's issued to the CTS engineer. So this is what they'll be working with as they walk through the process with the customer representative. It does illustrate a couple of features of the app. One of the things we wanted to make sure, especially for the North American side, that we had is something to allow to switch between metric and imperial units. All of our technical data at its core is developed in metric, However, in North America, we end up using standard units most of the time. And so this app will switch back and forth and convert those values back and forth as necessary. We also have the ability to customize the line name or even the specific product that the process check is being run on. So you can have different reports for different lines in your factory. If you have 4 or 5 products that run on the same line, you can have one process check for each of those different products and the process used for those. So you can customize this and document this as specifically as you think is necessary to get good value and use out of the tool. In addition, we can also take photos and insert those into the final report that's generated from this app. That can be important to add a picture of the product to help anybody who wants to read the report understand what the report covers. You can use it to take pictures of equipment or the lot number of the solder paste in use that day, or anything that might be helpful to document the current state of the process at the time. And there's 2 more buttons we'll talk about later. The results and the submit button are the ways we generate the final report after the process check has been walked through. What you see at the bottom here is an example of the first question, which is what pastes are we using? That's the most important thing because the recommendations will vary by the paste that you use. So what we've done is we've preloaded 21 of the most popular pastes that are used worldwide in the tool. And the first thing we do is select the proper paste to use for that process check. Now, this tool is developed to be a worldwide tool used in both Europe, Asia-Pacific, and the Americas regions. So there may be some paste on here that people on the webinar aren't familiar with. More than likely, those are ones that are available outside the North American region. But the primary ones that are used in North America are also represented by the list of paste available for use. All right, so this screen shows a screen cap from the printing process check. Basically, there's really 3 different categories of questions. We have some questions about the types of assemblies that are being produced, what's the market segment, some specifics of the design, the smallest area ratio that's used on that design. We also have some questions on the equipment. Some of these are for information, for example, what kind of printer brand do you use? But other ones are also important to use to identify the right limits for the process. Whether you're printing with squeegees or pressure cartridge, how you replenish the paste. Those are all questions that are captured in this app. And finally, and most obviously, we ask questions about the process. So we'll ask questions about the print process. What's the speed of your squeegee? What's the length of the squeegee? How much pressure are you applying? These questions will all be captured as part of the walkthrough that occurs between the CTS engineer and the customer representative. For solder reflow, it's a little bit different, but similarly structured. 3 categories of questions, assemblies, equipment, and process, except they're going to be more tailored to our ovens rather than printers. So what kind of oven do you use? Is it air or is it inert? What kind of profile have you developed, a straight ramp or a soak profile? And there'll be more questions about the actual specifics of your common profile or your most typical profile. And we'll compare all of this information to the guidelines that are provided in our technical bulletins for the use of our pastes. All right, so I mentioned earlier that there are 2 kinds of reports that are generated from this application. The first one is immediate, right? So the first one, there's a check results button that the engineer has on the app, and that button brings up a list of all of the questions that actually have a recommendation to compare to. And it highlights 3 types of conditions. The first type we highlight in pink indicates that the answer given is a process setting that is outside of our recommended range. And you can see an example of that on the screen here when you have, for example, peak temperature. In this hypothetical case, peak temperature was answered to be between 240 and 255. Well, it's a little higher than our recommendation. So it provides what the recommendation is, and also provides an explanation as to what the recommendation is and why that recommendation could be important. We don't want to highlight these in red because this is not meant to imply there's some kind of defect or something that's done improperly, but this may recognize an area that there could be some improvement. And this can spur a discussion. Like Frank mentioned at the beginning, these tools are meant to spur discussion about the process and what's best for the assembler, the product that's in place, the customer, the materials. And so in this case, we referenced that, if you reduce that peak temperature, you may be able to reduce voiding. Well, if you run a process where voiding isn't an issue, maybe that's not something that's important. However, if you're soldering a micro BGA that's got high density, yes, that's something we're going to want to pay attention to. and that can identify an area where we can improve the process and possibly improve the capability and quality of the products coming out of that process. The second type of category is going to be highlighted as yellow. Those are ones that are close to the limit of the recommended range. My hypothetical doesn't have any here. These are ones where you're within the guidelines, but you're at the very edge of the guidelines, where there's a risk that some process variation could push you outside of the recommended range. And then finally, and hopefully all the answers come into this category, is the green category. This indicates that the answer given was within the recommended guidelines and should represent a very robust process based on our recommendations for use of the product. Now, the second type of report is actually more of a follow-up report. This is generated when the engineer clicks the submit button. And so what that does is that uploads the report to a centralized database that Alpha has that contains all of the reports run by all the engineers across the world. This is going to provide a PDF summary of basically the same thing we saw on the last slide, the answers to the questions, and then a comparison of that answer to the recommendations for the product in place. It adds a fourth category. There's what we call the blue category. That's really just an observed values category. You know, which oven are you using? How often do you calibrate your printer? Right? There really is no right or wrong answer for this, but it's something that you want to document and make sure that you at least have an idea of current state there. In case down the road there are changes are made, or if there is something there that may indicate an opportunity to improve something in the process. So what you see here is an example where, in this case, the humidity level came in lower than our recommended range. So it highlights the answer, it highlights the recommendation for that material. And again, this can start a conversation with the tech support engineer. We can look at the process and see, well, if you have defects that are related to this potential cause, there's an area where we can possibly reduce those defects and improve the quality of the process. One of the nice things about these reports is that they can be shared with people outside of the Alpha and customer relationship. So you can provide these reports to your end user, to your OEMs, if you're an EMS or a subcontractor in a tiered situation, that can demonstrate that you're engaging with your suppliers, that we've come in and worked with you to ensure your process is as optimized as it can be. And that gives them more confidence in the quality of the product they're receiving from their suppliers. In situations like this hypothetical where the humidity level is too low, there really is no quick fix for that. You can't just snap your fingers and make the humidity be higher in the wintertime in New England. But maybe there's an opportunity here where the manufacturer recognizes that they may need to do some work on the environmental controls in the facility to improve the humidity level and better control there. After that project has been implemented, we can go back, we can update the answers in the report and generate a new report dated with the current date that shows the process now has been improved to alleviate this potential concern. So these written reports really kind of act as living documents within the database and can be gone into down the road and updated with any changes that have been made in response to the application and the answers we find in here. So that's a quick summary of the tool itself. What I would say to anybody listening that's interested in using this is to contact your local Alpha sales representative or a member of the CTS team and to discuss with us arranging an on-site visit for us to go through your process with you and try to work through and run these applications, provide you these reports, and provide you any advice, recommendations for better material, training, anything that might be needed to improve the quality of the products that you're generating and producing in your process.
Yeah, Jason, I might add, really, maybe the first point of contact is your HISCO professional. Whoever's responsible for your account from HISCO, that may be your first point of contact.
Yeah, I always recommend the customers contact their local contacts first because
right.
The CTS group, we have pretty large territories, so sometimes you can get lost in the noise of our day-to-day contacts with our customers. But if it's reported locally to your local sales staff, your local channel partner, that way they can keep driving us to get on the schedule and schedule a trip out to see the customer.
Right. Okay. Jason, is that all?
That's all I have.
Well, very good. Certainly appreciate it. Again, this is Robert Wallace. I'm going to go ahead and wrap up. But before I do, let me just a couple things. First and foremost, the process checklist app that Jason just walked you through is an internal app for our customer tech services engineers. Again, it's a tool that we would utilize. It's in beta site form now. It's not in full release. But we wanted to demonstrate to you the emphasis we've placed on making sure that we add value to our customers by providing very good insight and help into maybe potential problems that you're having. And in this case, it's a formalized method, takes us, our engineers, step by step, and more importantly, it generates a nice report at the end. Okay?
If I can add one thing, Robert. One of the things, I was one of the beta testers for this app, and one of the restrictions our development license has is that we're only allowed to distribute the app within our organization. So the app itself is only going to be resident on the iPads that are issued by Alpha to the CTS engineers. Just to make it clear that it's not something we can distribute the app. You can't go to the App Store and download it and use it yourself. That's right.
Good point. Okay, Dave, was there any typed questions?
Not at this point. If anybody would like to ask a question, please type it in the chat box at the bottom of your screen.
Okay, so while we're waiting on potential questions, again, as a recap, the two troubleshooting guides that were presented earlier, the surface mount and the wave solder, you're going to be getting an electronic copy of that from Hisco that we'll email that out to you. There should be a link as well to an ebook of white papers of related technical articles and past white papers that we have authored. If there is ever a question or a concern that you have with the use of our products and you need help to solve a potential problem that you're having, we encourage you to engage with your Hisco field sales professional and or your Alpha field sales professional. Those folks are very, very good at, if not being able to solve a problem, which likely they should be able to, but triaging an issue and then escalating that up to our customer tech services group, who we've just introduced to you. And those professionals will take the ball from there and make sure you get the help that you need and we help you solve a problem. I would encourage you as well to visit the Hisco website and look at the lineup of webinars that we have coming up. Again, tomorrow is our LED webinar that we basically walk you through the basics of LED. We introduce you to our product portfolio for LED applications, and we step you through the different levels of assembly, or the hierarchy of assembly of LED, and that's levels 2 through 5, and maybe where the Alpha products fits into those particular processes. So visit the Hisco website, sign up for that webinar or any webinar coming up. We repeat the whole series the first week in August. All right, Dave, do we have any questions?
Yes, someone in the audience would like to know, how large is Alpha's CTS team currently in the United States and Mexico?
That's a very good question. I can answer that, or Frank, would you like to answer? Frank may be muted.
Okay, Frank.
Yeah. Thank you. I was looking for my mute button. Yeah, currently there are 5 Alpha CTS engineers covering North America. We have on order of 30 engineers globally.
So 3 in the United States, 2 in Mexico. The 3 in the United States also cover Canada, and then we have 2 resident for Mexico and Central America, but mostly focused in Mexico.
Yeah, we don't focus so much on territory anymore in North America because there's so much between U.S. and Canada and Mexico. A lot of companies really span that whole area. So we span that whole area as well as needed.
Got it.
Okay, I think we're at the top of the hour, Robert.
Dave, we couldn't have planned that any better. Okay, so on behalf of our Hisco colleagues and our Alpha colleagues, again, we wish to thank you for attending today's webinar. We know you're extremely busy. We hope that this was of value to you, and we hope that certainly through our efforts, the products that we supply to you are well utilized in your facility and your process, And if there's any concern, any question with defects that maybe or problems that you're having that you can't fix on your own, by now, hopefully you have been introduced to our customer tech services group, at least in the Americas here, and certainly reach out to those professionals and we will provide the assistance that you need. So again, this is Robert Wallace with Alpha. Thank you for your attendance and hope to see you on tomorrow's webinar. Check the HISCO website for upcoming webinars as well. So without anything else, I guess that'll do it. And everybody have a great day.
Thanks, Robert.